100 Facts about Graphs. Basic graph concepts. 1. A graph is a mathematical representation of a set of objects, vertices or nodes, connected by pairs of objects, edges or arcs. 2. Graphs can be directed or undirected. In directed graphs, edges have a direction, while in undirected graphs, edges do not. 3. Graphs can be weighted or unweighted. In weighted graphs, each edge has a numerical value associated with it, often representing a distance, cost, or capacity. 4. The degree of a vertex is the number of edges connected to it. 5. A graph with no cycles is called acyclic. 6. A connected graph is one where there is a path between every pair of vertices. 7. A complete graph is one where every pair of vertices is connected by an edge. 8. A tree is a connected acyclic graph. Types of graphs. 9. A simple graph has no multiple edges between the same pair of vertices and no self-loops. 10. A multigraph can have multiple edges between the same pair of vertices. 11. A pseudograph can have self-loops. 12. A bipartite graph is one where the vertex set can be partitioned into two disjoint sets such that no edge connects vertices in the same set. 13. A planar graph is one that can be drawn on a plane without any edges crossing. 14. A directed acyclic graph, DAG, is a directed graph without any cycles. Graph algorithms. 15. Breadth first search, BFS, is a graph traversal algorithm that visits all vertices in a level-by-level manner. 16. Depth first search, DFS, is a graph traversal algorithm that explores as deeply as possible along each branch before backtracking. 17. Dijkstra's algorithm is used to find the shortest path between two vertices in a weighted graph. 18. Bellman-Ford algorithm is used to find the shortest path between a single source vertex and all other vertices in a weighted graph, even if there are negative edge weights. 19. Floyd-Warshall algorithm is used to find the shortest path between every pair of vertices in a weighted graph. 20. Kruskal's algorithm is used to find the minimum spanning tree of a weighted undirected graph. 21. Prim's algorithm is another algorithm used to find the minimum spanning tree of a weighted undirected graph. Graph theory applications. 22. Graphs are used to model networks, such as computer networks, social networks, and transportation networks. 23. Graphs are used in graph databases to represent and query data relationships. 24. Graphs are used in machine learning for tasks such as clustering, classification, and recommendation systems. 25. Graphs are used in computer vision for tasks such as image segmentation and object recognition. 26. Graphs are used in bioinformatics to study biological networks, such as protein-protein interaction networks. 27. Graphs are used in game theory to model strategic interactions between players. 28. Graphs are used in operations research to solve optimization problems, such as the traveling salesman problem. Graph representation. 29. Adjacency matrix is a square matrix where rows and columns represent vertices, and the elements indicate the existence or weight of an edge between the corresponding vertices. 30. Adjacency list is a data structure where each vertex is associated with a list of its adjacent vertices. 31. Incidence matrix is a rectangular matrix where rows represent vertices and columns represent edges, and the elements indicate the incidence of an edge on a vertex. 32. Edge list is a simple list of edges in the graph. Graph properties. 33. The chromatic number of a graph is the minimum number of colors needed to color the vertices of the graph such that no adjacent vertices have the same color. 34. The girth of a graph is the length of the shortest cycle in the graph. 35. The diameter of a graph is the maximum distance between any two vertices in the graph. 36. The connectivity of a graph is the minimum number of vertices that need to be removed to disconnect the graph. 37. The planarity of a graph determines whether it can be drawn on a plane without any edges crossing. 38. The Euler characteristic of a graph is a topological invariant that relates the number of vertices, edges, and faces of a planar embedding of the graph. Graph transformations. 39. The complement of a graph is a graph with the same vertex set as the original graph, but with edges connecting all pairs of vertices that were not connected in the original graph. 40. The line graph of a graph is a graph where the vertices represent the edges of the original graph, and two vertices in the line graph are connected if the corresponding edges in the original graph share a common vertex. 41. The subdivision of an edge in a graph is the operation of inserting a new vertex on the edge, dividing it into two new edges. 42. The contraction of an edge in a graph is the operation of merging the two endpoints of the edge into a single vertex. Graph algorithms and complexity. 43. The time complexity of BFS and DFS is O, V plus E, where V is the number of vertices and E is the number of edges. 44. The time complexity of Dijkstra's algorithm is O, V plus E, log V, using a min heap. 45. The time complexity of Bellman-Ford algorithm is O, V. 46. The time complexity of Floyd-Warshall algorithm is O, V cubed. 47. The time complexity of Kruskal's algorithm is O, E log E, using a disjoint set data structure. 48. The time complexity of Prim's algorithm is O, V plus E, log V, using a min heap. Graph visualization. 49. Graph visualization is the process of representing graphs visually to aid in understanding and analysis. 50. Common graph visualization techniques include node link diagrams, adjacency matrices, and circular layouts. 51. Graph visualization tools can be used to create interactive and dynamic visualizations of graphs. Graph theory in real-world applications. 52. Social network analysis uses graphs to study relationships between people and organizations. 53. Transportation networks are modeled as graphs to optimize routes and schedules. 54. Computer networks are represented as graphs to analyze connectivity and performance. 55. Biological networks, such as protein-protein interaction networks, are studied using graph theory. 56. Recommendation systems use graphs to suggest items based on user preferences and relationships between items. 57. Game theory uses graphs to model strategic interactions between players. 58. Urban planning uses graphs to analyze the layout of cities and transportation systems. Graph theory in mathematics. 59. Graph theory is a branch of combinatorics that studies graphs and their properties. 60. Graph theory has applications in various areas of mathematics, such as number theory, geometry, and topology. 61. Graph theory is used to study problems such as coloring, matching, and partitioning. 62. Graph theory is used to prove theorems in other areas of mathematics. Graph theory in computer science. 63. Graph algorithms are used in many areas of computer science, such as algorithms, data structures, and artificial intelligence. 64. Graph theory is used to design efficient algorithms for problems such as shortest path, minimum spanning tree, and network flow. 65. Graph databases are used to store and query data that can be represented as graphs. 66. Graph theory is used in computer vision for tasks such as image segmentation and object recognition. Graph theory in physics. 67. Graph theory is used to study networks in physics, such as neural networks and quantum networks. 68. Graph theory is used to model complex systems, such as ecosystems and social systems. 69. Graph theory is used to analyze the structure of materials, such as crystals and polymers. Graph theory in chemistry. 70. Graph theory is used to study molecular structures and chemical reactions. 71. Graph theory is used to design new drugs and materials. 72. Graph theory is used to analyze the properties of molecules, such as their reactivity and stability. Graph theory in biology. 73. Graph theory is used to study biological networks, such as protein-protein interaction networks and gene regulatory networks. 74. Graph theory is used to analyze the structure and function of biological systems. 75. Graph theory is used to identify patterns and relationships in biological data. Graph theory in engineering. 76. Graph theory is used to design and analyze networks, such as transportation networks and communication networks. 77. Graph theory is used to optimize the design of structures, such as bridges and buildings. 78. Graph theory is used to solve problems in control theory and robotics. Graph theory in social science. 79. Graph theory is used to study social networks and social interactions. 80. Graph theory is used to analyze the spread of information and ideas. 81. Graph theory is used to study the dynamics of groups and organizations. Graph theory in economics. 82. Graph theory is used to study economic networks and supply chains. 83. Graph theory is used to analyze the behavior of markets and firms. 84. Graph theory is used to design efficient allocation mechanisms. Graph theory in psychology. 85. Graph theory is used to study the structure of the brain and the organization of knowledge. 86. Graph theory is used to analyze social interactions and group dynamics. 87. Continuing from fact 87. Graph theory in psychology, continued. 88. Graph theory is used to study the development of cognitive abilities and problem-solving skills. 89. Graph theory is used to analyze the relationship between personality traits and social interactions. 90. Graph theory is used to study the impact of technology on social relationships and mental health. Graph theory in education. 91. Graph theory is used to analyze the structure of educational curricula and learning materials. 92. Graph theory is used to study the relationships between students, teachers, and schools. 93. Graph theory is used to design personalized learning experiences. Graph theory in law. 94. Graph theory is used to analyze legal networks and relationships between legal entities. 95. Graph theory is used to study the impact of legal regulations on society. 96. Graph theory is used to analyze the effectiveness of legal systems. Graph theory in sports. 97. Graph theory is used to analyze the structure of sports networks and relationships between teams and players. 98. Graph theory is used to study the strategies used by teams and players. 99. Graph theory is used to predict the outcomes of sports events. Future directions in graph theory. 100. Graph theory is a rapidly growing field with many potential applications in various areas of research and practice. 101. Future research in graph theory will likely focus on developing new algorithms and techniques for analyzing large and complex graphs. 102. Graph theory will continue to play a crucial role in addressing complex challenges in fields such as artificial intelligence, machine learning, and data science.